Please note that filming text on a whiteboard requires extremely bright studio lighting. Subsequently, sunglasses were worn during the filming of this video to prevent damage to my retinas. A note on how to use these sessions. Jot down the notes as we go, so we'll help you learn the material in a more interactive way and you can use them as study notes later. Also, in the small chance that a discrepancy arises between the professor's notes and mine, always go with your professor. They're the one grading you. Lastly, any examples or analogies used in this session are not meant to support or criticize politics, religion, or lifestyle. They're merely learning tools to help understand the material. Alright, guys and girls. It's time to get cracking.
Alright you guys, today we're going to be talking about acids and bases. And there are two main theories on how you can define an acid and a base. Do any of you guys remember one of those two theories? Well, from GChem, you guys probably talked about the Bronsted Lowry Theory. And this defined acids and bases in terms of hydrogens. Today we'll talk about a second theory which is called the Lewis theory. And this defines acids and bases in terms of electrons. Okay, so we've got two main theories, the Bronsted Lowry theory and the Lewis theory. These are just talking about acids and bases from two different perspectives. Bronsted Lowry talks about it in terms of hydrogens, in terms of protons, versus Lewis theory, which talks about acids and bases in terms of electrons. Okay, so let's write some of this stuff down. Alright, so we're saying that there's two theories on how we can define an acid and a base. We've got Bronsted Lowry theory, which defines acids and bases in terms of protons, in terms of hydrogens. And hey, you guys, when we say hydrogens and protons, those are synonymous terms because hydrogens consist of one proton. Okay, so Bronsted Lowry theory, these talk about acids and bases in terms of protons, in terms of hydrogens, versus the second theory, which is Lewis theory, which talks about acids and bases in terms of electrons. Okay, so we'll talk about both of these today, but let's start out with the more common way to define acids and bases, the Bronsted Lowry theory, right? Okay, so if Bronsted Lowry theory defines acids and bases purely in terms of protons, in terms of hydrogens, how would you expect Bronsted Lowry theory to define an acid? Would you expect this to be a proton donor or a proton acceptor? A hydrogen donor or a hydrogen acceptor? 50-50 shot here, right you guys? An acid, according to Bronsted Lowry theory, is going to be a hydrogen donor. Okay, so any compound that can give up a hydrogen, that can donate a hydrogen, that can have a hydrogen taken off of it, that's going to be an acid. Okay, so if you guys ever see a compound that has a hydrogen on it, technically that compound is considered an acid because it has a hydrogen that it can potentially give up to someone. Okay, that's not to say that it's going to give up that hydrogen, but it does have a hydrogen that it can potentially give up to someone. Okay, so that's all Bronsted Lowry theory is saying. An acid is a compound that has a hydrogen that it can give up, okay, that it can donate. Okay, so if an acid is a hydrogen donor and acids and bases are opposites, then what do you think a base is going to be defined as, according to Bronsted Lowry theory? Well, if an acid is a hydrogen donor, then a base is going to be a hydrogen acceptor, right you guys? Hydrogen acceptor. Okay, so if you ever see a compound that can accept a hydrogen, that can take a hydrogen, that can rip a hydrogen off somebody, that's going to be considered a base. And it accepts these hydrogens, it takes these hydrogens by using lone pair electrons. Okay, so if you ever see a compound that has lone pair electrons, that technically can be a base because it potentially can use those electrons to grab a hydrogen with. Okay, so that's not to say that it's definitely going to grab a hydrogen, that it's going to accept a hydrogen, but it does have a lone pair electron to possibly grab a hydrogen, making it a base. Okay, so let's say this one more time. An acid is just a compound that has a hydrogen, okay? If it has a hydrogen, it could potentially donate it to somebody. A base is any compound that can accept a hydrogen, and it accepts these hydrogens by using lone pair electrons, okay? So that's all an acid and a base is, hydrogen donors and hydrogen acceptors. Okay, so now that you know what an acid and a base is, let's spell out what happens in a Bronsted Lowry acid-base reaction. Okay, so RXN, reaction. And all that's going to happen in this acid-base reaction is that a base is going to take, so a base takes a hydrogen, and I'm going to put this hydrogen in big block letters because I want you to understand that the only thing happening here is that a base takes a hydrogen from, who do you think this base is taking this hydrogen from? An acid, right, you guys? Okay, so all that's happening in this acid-base reaction is that a base takes a hydrogen from an acid. Another way of saying this is that an acid donates, it gives a hydrogen to a base. Okay, so you could think of it whichever way you want. Okay, so we're going to do an example of what an acid-base reaction actually looks like. But before we do that, I just want to do a quick demonstration to make sure that this concept is crystal clear to you guys. Because for me, I think I took a year of general chemistry, a quarter of organic chemistry, before understanding what an acid and a base actually was. And it's like, that's so ridiculous. How do I not know what an acid and a base is? Like, I knew hydrochloric acid was an acid. I knew sodium hydroxide was a base, but I didn't really get what made something an acid, what made something a base, and what was going on in this whole acid-base reaction thing. And I just want to let you guys know it's very simple. All that's happening in an acid-base reaction is that a base takes a hydrogen from an acid. So one compound, an acid, is going to give up a hydrogen to another compound, the base. Okay, so let's see a quick demo on how this happens. Alright, you guys, so in this demonstration, all I'm trying to illustrate to you guys is that an acid is a hydrogen donor. Anyone that gives up a hydrogen is an acid. A base is anyone that accepts a hydrogen, that can take a hydrogen off somebody, okay? So hey, in this demonstration, my buddy John from high school is going to be helping us out. And hey John, we took high school chemistry together. Did you have a favorite acid from Mr. Bartlett's class?
Hydrochloric acid.
Hydrochloric acid, awesome. I predicted you would say hydrochloric acid. Okay, 9 out of 10 people, you ask them what their favorite acid is, they say hydrochloric acid. Okay, that's how I predicted that. Go home and try it sometime. But hey, anyways, you guys, in this demonstration, I'm going to be playing the part of hydrochloric acid. Okay, so hey, I'm going to be this chlorine. My arm is going to be a bond connecting me to this hydrogen. Together, we are considered hydrochloric acid. And if you want to see what this looks like on the board, you guys, all this is an H covalently bonded to a chlorine. Okay, so, all right, I'm going to be this chlorine right here. My arm is this bond in between this chlorine and this hydrogen connecting me to this hydrogen. Remember, a bond is just made out of 2 electrons, so my arm is just 2 electrons bonding me to this hydrogen. Okay, so and I'm playing the part of HCl and acid. Jonathan's going to be playing the part of Jonathan the base. Okay, so let's see what happens in a Bronsted Lowry acid-base reaction. All that's going to happen is, okay, I'm HCl, I'm an acid, I'm walking along one day minding my own business, holding on to my hydrogen, right? When all of a sudden Jonathan the base comes out and he says, hey Garrett, give me your hydrogen, right? And I'm like, okay, go ahead and take it, you know, just don't hurt me, right? And this turns me from HCl to a Cl all by myself, okay, a Cl minus, all right? So, hey, it's not all bad though, you guys, because check out what happened here. Remember when I was HCl, I was a chlorine covalently bonded to this hydrogen. What did we say my arm stood for? We said my arm stood for 2 electrons, right? So when Jonathan takes this hydrogen, does he take the hydrogen and my arm along with it, or does he just take the hydrogen? He just takes the hydrogen, right? I still have my arm, I still have the 2 electrons, the lone pair, that I can now use to go and grab a hydrogen off someone, that I can go and accept a hydrogen off somebody with, right? So hey, you guys, at this point, you guys, when I'm a chlorine by myself, am I still considered an acid? No, right, you guys? Do I still have a hydrogen that I can give up? No, right, you guys? So I'm no longer an acid. I don't have a hydrogen on me that I can donate to anybody. Even if John came up to me with a gun to my head and asked me for a hydrogen, I still couldn't give him one, right? I don't have any more hydrogens left. But hey, check out what I do have now, you guys. When John took off my hydrogen, I now have a free hand, a free lone pair to go and try to grab other hydrogens with, to accept other hydrogens with. So hey, if I now can accept hydrogens, you guys, what would you now call me? I am now a base, a hydrogen acceptor, right, you guys? So hey, what happened was I went from HCl, an acid, to Cl by itself, a base, right, you guys, since I have a free lone pair to go and grab other hydrogens with, okay? And we call this the conjugate base. So we call it the conjugate base of HCl. HCl is the acid. Cl minus by itself is considered the conjugate base, okay, because they come in pairs. HCl turns into Cl minus, they're pairs with each other, right? Okay, so now that you've seen my side of the story, the acid side of the story, now let's look at Jonathan, the base's side of the story, okay? So, hey, this starts out with me as HCl. Jonathan's a base. He has a free lone pair. He has a free hand, right, that he can, go and shake your hand, John. He has a free hand that he can come pick up hydrogens with, right? So, hey, he picks up my hydrogen, turning him from a base now to a, guess what he has now? He now has a hydrogen that he can give up to somebody, that he can donate to somebody. And if Jonathan now has a hydrogen to donate to somebody, what do you now call him? A hydrogen donor is called an acid, right, you guys? So, hey, Jonathan the base turned from Jonathan the base to Jonathan the conjugate acid, okay? So, hey, check out what happens here. I turned from an acid to a conjugate base. Jonathan turns from a base to a conjugate acid, right? And the only thing that's happening here is that we're transferring hydrogens back and forth. That's the only thing that happens in an acid-base reaction, okay? Whoever has the hydrogen is going to be the acid. Whoever has the lone pair, the free hand to accept a hydrogen, is the base. So hey, right now I'm the acid, he's the base. He's now the acid since he has the hydrogen. So whoever has the hydrogen is the acid. I'm the acid. He's the acid. Now I'm the acid, okay? So whoever has the hydrogen is the acid. Whoever has the hydrogen is the hydrogen donor. That's an acid. Whoever has a free lone pair, a free hand, that's a hydrogen acceptor. That's a base, okay? And that's all that happens in an acid-base reaction. So hopefully now, you guys, it should be painfully clear what an acid and a base is. An acid is anything with a hydrogen that can give it up. A base is anyone with a free lone pair that can accept a hydrogen, okay? Alright, so I hope you enjoyed that demonstration, but now let's go ahead and write down the general reaction for an acid-base reaction according to Bronsted Lowry Theory, alright? So basically you're just going to take an acid, add it to a base, throw in some equilibrium arrows, and hey, an acid, after it gets deprotonated, turns into a conjugate base, right? An acid turns into a conjugate base, and I'm abbreviating this C base, conjugate base. Okay, so an acid gets deprotonated, turns into a conjugate base. A base, on the other hand, gets protonated, gets a hydrogen attached, so a base turns into a conjugate acid. Right, you guys? Okay, so basically what's going on here is that this acid in the beginning started out with a hydrogen. This base ends up jacking this hydrogen, turning this acid into a conjugate base, and this base into a conjugate acid. Now this is going to have the hydrogen attached, okay, you guys? So the only thing that happened was that this H transferred from the acid to the base, turning this acid into a conjugate base and the base into a conjugate acid, okay? But enough theoretical examples. Let me show you an actual example now, okay? Alright, so for example, you guys, let me just throw in some HCl with some NH3. And let me draw this nitrogen's lone pairs nice and big, okay? And don't forget your equilibrium arrows, right? Acid-base reactions happen in equilibrium, and you'll find out what that means in just a second, okay? But what's going to happen in this reaction is you have HCl, hydrochloric acid, and you have NH3 here. Nitrogen has a lone pair on it, right? So what's going to happen is that this acid is going to donate this hydrogen to this base. So if you look at nitrogen, nitrogen has a lone pair on it, right? A lone pair is just like an arm that can grab a hydrogen off somebody, right? So nitrogen is your base, so this base is going to go and grab this hydrogen off of this chlorine, turning this HCl into Cl-, turning this acid into a conjugate base, turning this base into a conjugate acid. So, hey, NH3 is going to go and grab this hydrogen, kick the electrons to chlorine, turning this HCl into Cl-, and this NH3 is going to pick up this hydrogen and get turned into NH4+. So it's going to be NH3, but it's now going to have picked up that extra hydrogen, turning it into NH4+, okay? So if you can't mentally see what's going on here, you guys, let's go ahead and draw in the curved arrows, okay, so you can see actually what's happening.